In this video, we'll learn about the basics of interior lighting in Arnold for Cinema 4D utilizing Arnold Sky, Distant Light, and light portals. For this lesson, I'll be using this classroom scene. We have all these beautiful windows that let a lot of light to shine through and enter the classroom. As always, I'm using ACE's workflow, and ACE's really helps with this type of scenes where you need tons of light without having burnout highlights, especially near the windows and other openings. And I don't remember how I used to work before ACES. It is such an essential part of my workflow right now. Let's run the IPR and start with an Arnold sky. We can use physical sky, but for now we stick with a simple white sky. To let more light into the room, increase the exposure of your sky, in this case to around 4. The color of the sky can remain at white. Instead of this, you can add a slight tint of blue to better represent the actual sky, or you can assign an HDRI image, but for now, let's keep it as simple as possible. Before adding our sun, we need to deal with the noise a bit. Let's add diffuse direct and indirect AOVs so we can figure out where the noise is coming from. You notice both our diffuse direct and indirect passes are really noisy. The first step is to use a light portal. Now, what is a light portal? It basically guides the samples from the Arnold sky into the room. You put a light portal behind your windows and they tell the Arnold sky to focus the sampling through them and into the interior scene. Let me stop the IPR and make sure the sky is not visible in the viewport because it's a bit distracting. Now add a light portal and place it right behind the windows, covering it completely. You need to make sure by looking at this white line that comes out of the light portal that the light portal is pointing towards the windows. So let's position this. Now, if we take a snapshot from the IPR and start the IPR again to see the effect of the light portal, if I stop this render as well and take a snapshot and compare it with our previous render, you see with the same render time, we have a cleaner render. It's still very noisy, but we get like 15-20% improvement without having to sit for longer renders. The same render time, but cleaner results thanks to the light portal. Now, if I go to the diffuse direct pass, you see it's really noisy. And as you know, this pass is diffuse direct lighting pass. To clean this noise, select it and set its samples to around 5. Now we get a much cleaner direct lighting from our sky, but the indirect lighting is still very noisy. Before working on the noise there, let's think about our diffuse ray depth or our indirect GI bounces. Right now, diffuse ray depth is set to 1. That means when the skylight hits a surface, it can only bounce once, which is absolutely unacceptable for an interior shot like this. You need at least 3 or 4 bounces. For now, let's set it to around 3 indirect bounces. And now we get a much brighter and more physically accurate render. The diffuse indirect AOV, as I mentioned, is very noisy. We deal with that at the end, as increasing the diffuse sample will result in much longer render times, and we want to keep it as fast as possible while working on the render. Next, I want to add the sun using a distant light that we learned about it in a previous lesson. So let's add one. And first set its exposure to around 6 so we can see it coming through. We can rotate the distant light and decide on how you like the light to shine through. In this case, let me set the heading of the light to around 45 degrees and the pitch to around negative 18 degrees. To get a bit more realistic shadow, set the angle to about 0.5, which as we learned previously is the angular size of the sun, and this will give us softer shadows. And to make sure these softer shadows wouldn't cause any noise, increase the sample value to around 4. Now, to get a tad warmer colors from the sun, we can turn on use color temperature and use something like 4500 degrees. You can use warmer colors or cooler tones depending on your scene and taste. And finally, we need to deal with our GI or our diffuse indirect noise. Now, to get an acceptable result, I know for this scene, I need around 2000 diffuse samples. We are using a simple Lambert shader on our entire scene. That's why we only concerned about diffuse sample. If we had any shaders with specular reflections, transmissions, or subsurface scattering, you need to make sure to increase those samples here as well. Now, to cover those basic requirements that we talked about in the sampling section of the course, I think we need at least 6 camera samples for such an interior shot, just so we get proper anti-aliasing. And a diffuse sample at around 8. And now, as you can see, we get around 2400 overall diffuse samples, which results in a much cleaner render. Even though it wouldn't be absolutely noise-free, you still get a bit of high-frequency noise, and to take care of that, we can use Arnold the Noiser tool. If I render the scene right now with a 1280 by 720 resolution, this would be the result. Let me just show you the render. Now, the render took about 9-10 minutes on this machine with a Threadripper 3970X. And if we look around, we still do see some high frequency noise and grain around. To get a completely noise-free render, we can feed this render to Arnold the Noiser, which you can find it as a separate tab in your render settings. And with the default values, we can get this denoised version of our render. Let me show you here. So as you can see, this is the noisy original render. We have these high frequency noises, especially in the dark areas, they are much more visible. And then we feed this render into Arnold the Noiser, which results in this noise-free, absolutely clean render. Even though we'll be covering Arnold the Noiser in the rendering section of the course, but as Arnold is famous for hard to clean interior shots, we take a look at the denoising workflow right now briefly as well. So let's get back to Cinema and prepare for the final render. Let's say we are happy with the lighting and shading and we want to render for denoising. We know we have a complex shot and we don't want to go through the roof with the render settings and the render time. So we want Arnold the Noiser to take care of those impossible to clean noises. So go to the Arnold the Noiser tab and under this input section, and here you can find this create EXR driver. You need to click here to add an Arnold the Noiser driver. And this driver will save out your final render. It's a normal Arnold driver that you can create it manually using Arnold menu, but this one comes with this output Arnold the Noiser AOVs checked. The output driver has to be EXR as we are rendering with ACES. Now in the main tab, define where you want to save your EXR file. For now, we can save it to the desktop and name it whatever you want. Obviously, I have rendered it before. Let's name it 0309_test. And I will also enable half precision to get a 16-bit EXR instead of a 32-bit one. Now we can start our render using this render to picture viewer button. As I mentioned before, because we are in ACES, the render will look wrong and horrible in the picture viewer, but the saved EXR file will be correct. I have already rendered the shot. When the render is done, we need to get back to the denoiser tab in our render settings and load our render in this input field. Our render was called 0309 underscore test. So load it here. In the output field, you can define where the denoised version will be saved. It automatically saves it to the same place as the input, but adds a denoise suffix to the end of the string, which is good enough for now. So we go through these denoise settings in its specific lesson, but for now the default values are sufficient. And finally, click on this denoise button. And after a few seconds, it says that the denoising is complete and you can load the result in the picture viewer or locate the folder where it was saved. As I mentioned, let me just save it to show it in the picture viewer. As I mentioned previously, because we are using ACES, the render does not look correct in the picture viewer, as Cinema 4D's picture viewer does not support ACES at the time being. And we need to use a compositing app like Fusion to get a proper sRGB output in a format like JPEG or PNG. We'll learn how to do that in the ACES lesson in the rendering section of the course. But I can show you the final render before denoising and after denoising. And you see how perfectly clean it is, and we haven't lost any small details or features due to denoising, which is pretty cool. Now check out the denoising and the ACES videos if you want to in the rendering section of the course, if you're having any questions right now. So that's it. Now just to recap, first we added an Arnold sky as our environment. Then we used light portal behind the windows to get less noise from the sky. Then we increased the samples for the sky to get noise-free direct lighting from it. Next step was to increase the diffuse ray depth to get more indirect bounces from our light sources, which resulted in a brighter and more accurate render. We added the distant light with a warm color to work as the sun. And finally, we increased our diffuse samples for a clean GI or indirect diffuse pass. As we wanted an absolutely clean render, we used Arnold denoiser at the end. Now what I want you to do is, instead of using an Arnold sky and a distant light, try to see if you can get a nice interior render using only the physical sky that we learned about in a previous lesson. So that's about the basics of interior lighting in Arnold for Cinema 4D. See you in the next one.